This video segment examines greenhouse gas emissions from buildings and the potential for their mitigation. Its major points are: number 1, buildings emit about 25% of the greenhouse gases from human activity. Number 2, improved insulation, heating, ventilation, and air conditioning, lighting, and appliances are increasing the energy efficiency of buildings. Buildings, if one includes the greenhouse gases produced from off-site generation of electricity and heat, are the source of 2.9 gigatons of carbon equivalents per year, or nearly 1/4 of the worldwide total from human activities. For comparison, commercial transportation emits less than 0.3 gigatons of carbon equivalents per year. Space heating and cooling, water heating, and lighting consume most of the energy in commercial and residential buildings. Key to energy conservation in buildings is minimizing unwanted transfers of thermal energy from the interior to the environment, either by conduction, transfers of kinetic energy when one molecule bumps into another, convection, transfers of kinetic energy when one molecule moves from one place to another, or radiation, transfers of electromagnetic energy with wavelengths that excite the motion of molecules. These energy transfers depend on air and moisture leaks, insulation levels, thermal properties of windows and doors, and HVAC equipment. The outer shell of a building serves as a barrier to impede thermal transfers between the building and its surroundings. Air leaks driven by winds, by pressure differentials from mechanical ventilation systems, and by temperature differentials continually challenge this thermal barrier. Moisture leaks degrade the performance of insulation as well as influence humidity in a building and affect comfort levels. Infrared images are helpful in pinpointing thermal leaks from buildings and guide the installation of supplemental insulation, moisture barriers, and weather stripping. Adequate levels of insulation not only conserve energy, but also permit buildings to downsize their heating and cooling equipment. Building codes in most localities have extensive sections on insulation, and with every update tend to dictate more insulation. To meet code, contractors must tally the thermal properties of all building materials. Building insulation comes in many forms. The primary requirements of an insulating material are that it has a low thermal conductance and fills space to minimize convective transfers via air movements. Some insulation is covered with shiny foil to decrease radiative transfers, and others contain moisture barriers to minimize leaks. Certain types of insulation, such as polyurethane, have desirable thermal properties, yet their manufacture may require an inordinate amount of energy for materials and processing. Installing insulation during the initial construction of a building is less expensive than retrofitting an existing building. The mean lifetime of buildings, however, is 40 to 120 years, and adding insulation to older buildings may reduce their energy requirements by 12 to 40%. In some cases, a building has access spaces that will accommodate additional insulation or an insulating layer that may be applied externally. In other cases, foam may be injected into air cavities. Unfortunately, many of these foams release greenhouse gases such as carbon dioxide or halocarbons, CFCs or HCFCs. The payback time required for heating-related emission savings to offset emissions during manufacturing and installation, range from 10 years for non-halocarbon foams to 100 years for halocarbon ones.